In today's video, we are diving into something that's crucial for any AI enthusiasts or professionals: LangChain and text splitting strategies. So why do we even need to split text or documents? Well, when AI systems work with large chunks of unstructured data like PDFs or scanned documents, they can easily get overwhelmed. Splitting the data into smaller digestible pieces is what allows AI to understand and process it effectively. But here's the catch: getting the chunking right isn't as simple as it sounds. If done wrong, your AI can miss important details or fail to perform tasks like answering questions, generating insights, or making predictions. And that's where mastering chunking comes in. And if you're aiming for roles like AI engineer, GenAI developer, or machine learning engineer, this is exactly the kind of skills that's in high demand. It's a must-know for working on real-world AI projects that handle large amounts of data. So whether you're working on building smart search systems, data pipelines, or creating advanced AI models, chunking is a foundational skill. And in this video, we are diving into the essential chunking and splitting strategies, from basic recursive splitting to advanced token-based chunking. We'll explain how to choose the right method based on your data type and show you how to optimize the chunking process to avoid errors, especially when working with large documents or embeddings. And if you want to build hands-on experience with these strategies and land a high-paying AI job, just like Shrija, Mark, or Steve, you can check out our free AIML and Agentic AI masterclass. Head over to the description or pin comments to register. So now let's get into the video.
So the other notebook that I have shared, let's quickly check with that. So that talks about the different splitting strategies, splitting and chunking strategies. Okay. So let me connect my runtime. Okay. So this will also need to be restarted after you have installed the unstructured. So if you're doing everything in a local machine, then you don't have to every time reinstall. You can create a environment where all these things are pre-installed at once, and that environment can be reused for all these coding files. Okay. So you can create a requirement.txt file and do that. So let me restart. Okay, so it is restarted. Now I am also installing the OCR dependencies like Poplar and Tesseract. So OCR means optical character recognition. So imagine a Word or a PDF document where text is not recognized as text. It is like a image converted into PDF. So think that you have, let's say, driver's license or a PAN card, Aadhaar card. You have taken a photograph and that photograph has been saved as a PDF. But there is a text ultimately, right, in your license, Aadhaar card, SSN card, whatever. Okay. So how to recognize the text present in an image? And that is what the OCR does technically. Okay. So this unstructured library needs this Poplar and Tesseract. So Tesseract is actually a family of deep learning models. Okay. Good thing is Tesseract is completely open source. So all these models are freely accessible to us. Okay. So let's say I've got a simple document, okay, that I can use as recursive character text splitter. So this I have already explained, converted into a LangChain document. You can see this is a simple document, and I'm using the recursive character text splitter. I can provide the splitters. So if you see, there is a hierarchy. So this will separate into paragraphs. Paragraphs will be separated into lines, and lines will be separated into individual words. Okay. So that's how the hierarchy goes. Okay. You can specify the chunk size and if you want any chunk overlap. Okay. So all these we have explained. You can experiment all these numbers. So again, within different chunking strategies, again, there is another variable. Okay, fine. There is another variable, and that is the chunk size and the chunk overlap. So many of these chunking techniques will need the chunk size and the chunk overlap. And the definition of the chunk will also keep changing. For example, in this case, the definition of the chunk is the character. So how many characters? So 300 refers to the number of characters. There are splitters where the number refers to tokens. So that we will see. You have to be careful what these numbers are referring to actually. Okay, is it the number of characters or is it the number of tokens? So here, the name of the splitter itself says I'm going to split based on the number of characters. Okay, so that is how you are getting here. So you are printing all of your text, the first file. Now splitting with a larger chunk size, that means you have to increase the total number of characters. Okay, will give you less number of paragraphs. So earlier we got 5 and now you will get 3. Okay, you can just check. Fine. And then chunk overlap. So if you increase the overlap size, okay, of course there is some continuity which is maintained, but that will also increase the number of chunks. Remember that. Okay. So if yeah. So finally we have to create the LangChain documents. Okay. So once we have all these, so text splitter dot create document. So you are using the create document method to actually convert these into LangChain documents. What we have just done is split it into text, but these texts are not yet LangChain documents. So now when I create the documents method, then I am actually getting the LangChain documents out of these splits. So now I'll get the LangChain documents. You can see. Now this is a very basic splitter, so I'm not able to get any metadata. And anyway, this was not done by ingestion. This document was directly hard typed into the notebook. Okay. Usually the metadata comes from the document loader itself. The document loader directly passes the metadata information towards the chunker. Okay. So the loader and the chunker is usually used along a same pipeline so that the metadata information is passed. So each split gets its metadata from the loader, not from the chunker. The job of the chunker is just to maintain the continuity of the metadata. Here, anyway, we did not have the metadata. We directly have the document without metadata. So all the metadata for these documents are anyway empty for that reason. Okay. But if you're loading a document properly and then doing a chunking, even recursive character text splitter will ensure that the metadata information is passed on to each of the chunks properly. All right. So that includes pre-built list of separators that are useful for splitting text in specific programming language. Okay. So let's say I've got a Python code and I'm still using the recursive character text splitter. Okay, how can we split the code part? So there is a Python splitter which says, okay, from language, the language is language.python. So it's a Python language and then chunk size of 50. So basically now you are splitting the code. Okay, so if you see when I execute this, I get hello world. So this is the hello world, probably in the second document, and from here to here, it is the first document. Yeah, that's what we have got. Okay, so there are code splitters also. Okay, that is a good thing. And then we have markdown splitters, especially for markdown documents. So now we know the markdown loaders, and now we are having markdown splitters. Okay, so we might want to chunk based on the document structure. So Markdown is organized by headings, H1, H2, H3 headings. And if you want to create these chunks based on these header groups, that is also a good idea. Okay. So in this case, you can use the markdown header splitter function. Okay. So let's say I'm creating a simple markdown document. It's a very simple markdown document. Okay. So this is your H1 heading. The hash is your H1 heading. Two hash will give you H2 heading. Remember. Okay. This is your H1 heading. This is your H2 heading. This is a normal paragraph line text. This is again a H2 heading. Okay. And this closes my markdown format. Okay. So now you can specify which header to split on. Header 1 and then header 2. Okay. That you can. So now the content is grouped and splitted by the common headers. So header 1 is team introductions, header 2 is the management team, and you will get this as one document in that case. And then team introductions, that is the header 1, and header 2 development team. So this is the development team, and this will be the content of the second document in that case. So the advantage of doing this is the header 1 is passed automatically to the next chunk also. Okay. That is automatically passed to the next chunk also. That is the beauty. Okay. So let's do this. So here I have got my markdown document. So this is just for illustration sake, but yeah. So that's what exactly I told you. The header 1 information is automatically passed on. Okay. Because it keeps a track of the headers. So the actual chunking is happening based on the header 2. Okay. But the information of the header 1 is automatically passed to each of the second headers. Okay. So here the page content is the this last line. Okay. And yeah, whatever. So you can specify how many headers you want. In this case, we have only two level of headers. But if your document has multiple levels, that also you can use it here. So by default, Markdown header splitter strips headers being split on the form of the output document chunk. So this can also be disabled. Okay. So strip headers equal to false. And in that case, what is happening is, I mean, what is it trying to say? So if you see the page content part does not have the header information. So you have stripped the header information from the content. Content only has the content. That's it. Okay. But if you say strip equal to false, then the page content itself will also have the header name. Can you see? That will also have the header name. Yeah. So that you can decide whether you want to have it in the page content or not. Now we can have a tokenizer based splitting. So till now we have been discussing about character based splitting and now the token based splitting. So there are tick token. So what is tick? Remember this tick token library. So wherever you want to count the number of tokens for any given input or output, let's say you have 1000 pages. Simple scenario, you have 1000 pages that you have loaded. Now you want to estimate how much will be the charge, how much will be the cost of embedding these 1000 pages. So embedding does not happen by pages. Embedding happens by tokens. So 1000 pages has how many tokens of text that can be counted using the tick token. So it is the same library which has built by OpenAI. So if you're using OpenAI models, this is very, very helpful. Otherwise, if you're using the Hugging Face model, then each Hugging Face model has its own tokenizer. So you have to use the corresponding tokenizer to estimate the number of tokens. So this is very helpful to estimate the number of tokens. And another reason that we want to have is these embedding models from OpenAI, for example, has got a context length limit, let's say 8,000 tokens. So embedding 3 small, that model that embedding model, embedding small 3, okay, embedding 3 small, whatever it is, has got a context length of roughly 8,000 tokens, okay, which means if your chunk contains 10,000 tokens and you give that chunk for embedding, you'll get an error saying that context size has exceeded. You'll get an API error, as simple as that, okay. So now using the tick token library, you can estimate how much is the number of tokens in this chunk, exact number of tokens, and then make sure that it is less than the context size before it is actually given for the API call. Okay. Yeah. So what is tick token library? This is the library developed by OpenAI model, OpenAI company. And we can use the tick token library to estimate the total number of tokens before making an API call. Okay, before making any API call. So the example which I was giving you is, uh, for example, if you are giving for embedding, okay, embedding models have a context length. They cannot take any big block of text for embedding because if it exceeds the context length, it will not be able to generate the embedding. Okay, because these are deep learning models and deep learning models have a specific predefined length for the inputs, specific predefined length for the input. Okay. So when the model was trained, that was 8,000 something tokens. Okay, fine. But now as a user, how do I know for a given text, how many tokens it corresponds to? That is where this tick token library can be helpful. So whatever text that you have using the tick token library, okay, you just do the encoding. So when you do the encoding here, what is happening? It is converting. This is your encoder. This is your encoder. Now, encoder will generate the actual token IDs, you can say, or you can say tokens. Okay. So it will generate the token IDs. So the split will only split into words, but those words will be actually converted into tokens here. And once you are using the encoder.encode, that is the place where you will be able to get the token numbers out. Okay. So there are 27 words with exactly 30 tokens, and this is the chunk. So we have used the, if you see here, chunk size is 30. So the moment it became exactly 30 tokens, there was a hard stop. There was a hard stop. Okay. The moment it became 30 tokens, there was a hard stop. Fine. Yeah. Fine. So this is used to count the number of tokens in a given piece of text. That is what you can say. Again, larger chunks in terms of number of words will create lesser tokens. So if you increase from 30 to 100, the total number of tokens will reduce. Sorry, the total number of chunks will reduce, and each chunk will have more number of tokens. That doesn't matter. I mean, matter in terms of what? Um, no, it will matter actually, depending on what context you are seeing. Okay. So if you are increasing the chunk size, the number of chunks which get created is smaller, which means directly that you are making less number of API calls. So earlier we had 10 API calls to be made. You can think if you want to create the embeddings, you'll have to make 10 API calls because there are 10 documents. And now the moment I increase the chunk size to 100, I just have 3 chunks, which means I'll have to make only 3 API calls. So definitely this is a tunable parameter and which is very important. The only drawback could be if you increase the chunk size too much, then the information might easily get lost. Okay, or I would not say lost, but the model might still struggle to extract the exact information from these chunks. Okay, if the chunk size is too small. Okay, so ideally we want to have smaller coherent chunks which contain specific pieces of information. That is the whole objective. So the chunk size itself is a big tunable parameter. In fact, once you have a end-to-end RAG evaluation pipeline, you just run that pipeline for few chunk sizes and see which gives you the better performance. Okay. Big token is not defined. Acha, I forgot to run these. Anyway. So recursive character text splitter again. This is your chunk size. Now this is character size once again. Okay. If you want to implement a hard constraint to the chunk size, this is the better option, tick token encoder. Okay, so that you can do. And finally, we have the Spacy library. That is also a library for natural language processing, just like NLTK. So Spacy also has a text splitter. There also you can specify the chunk size and the chunk overlap. So you can get the splitting done from there also. So that is the Spacy split. I don't prefer to use a sentence transformer, so this part I'll skip, frankly. It is just there in the notebook, but I don't like the sentence splitter. So basically, this is a splitting based on a LLM model. Okay. So these are language models. So language models are doing the splitting for you. So the default behavior is to split text into chunks that fit the token window of the sentence transformer. So it will, create chunks as per its own requirement. Okay. This might be good if you are going to use another sentence transformer library for encoding or embedding. Okay. Once again, let me repeat the last statement. This might be good for those scenarios where you are going to use the chunks for embedding using a open source Hugging Face model. Then this might be beneficial, okay, because you are splitting based on that same model tokenizer, and then these chunks are directly compatible to your Hugging Face models. But if you are not using the Hugging Face models for embedding, I would like to skip this altogether, okay. It is just there to tell you that there is something based on LLM-based tokenization. Sorry, LLM-based splitting also does exist.
So that's a wrap on today's deep dive into chunking and splitting strategies. Whether you're processing text for embeddings or OCR recognition, knowing how to handle your document segmentation efficiently will elevate your AI skills. Also, don't forget to register for a free masterclass on AI/ML if you want to learn how to apply these techniques and land your dream AI role. Just click the link in the description or in the pinned comments to register. Also, if this video helped you, make sure to subscribe, give it a thumbs up, and share it with someone who's looking to master these skills. Also, make sure that you check our next video right over here.